In this tutorial we'll take a look at the internals of the workflow component of the Equipment Manager template. The Equipment Manager template, Template 1, ships as part of the CoreTegral installation. This is a continuation from the tutorial called Creating a New Solution using the Equipment Manager template. Let's start Visual Studio and open our Template 1 solution, which we called Solution 1. If you're following along from the previous tutorial, the solution was saved in the folder C, examples, Solution 1. At runtime, an instance of the workflow component is created whenever a new automation run on the equipment is started. The Equipment Manager component is responsible for requesting the workflow host component to start the workflow instance. It passes all the necessary setup information to the workflow. Let's explore the internal logic of the workflow. Double-click on the basic run flow open cassette.xaml file. At the top level of the workflow there is a try-catch construct to capture any unhandled exceptions. This calls the activity close run, which in turn terminates the automation run and performs the necessary notifications to solution components. The main logic of the workflow is a flowchart activity, named runFlow. If we select the runFlow activity, we can see the arguments passed into the workflow when it is started. Workflow host is a reference to the iCore workflow host interface of the hosting component in the solution. It is passed to all workflows when they are started and provides the mechanism for them to access other solution components. It can also be used to start other workflows if required. Run name is specific to workflows started by the Equipment Manager to manage runs. It provides the unique name of the run, allowing all associated data to be accessed from the database. The equipment configuration argument provides the configuration information relating to the equipment that we're automating. The type definition is part of the iCore equipment interface, and so can be relied upon to be the same for all equipment types. The additional equipment configuration argument optionally contains additional equipment type-specific configuration data. The Variables tab at the top level provides information on the global variables that are common to all the activities in the workflow. Event data is used to receive the data when any event is received into the workflow from a solution component. Activity success is a variable used by convention to hold the success or failure result of all the custom-coded workflow activities that are called from the workflow. Run object is a helper object providing methods for accessing data through the data access layer. It also provides logging functions and assistance communicating with other solution components. Run flow complete is a variable used whenever an activity has to complete the run for any reason. Let's dig a little deeper into the run flow. At this level within the flowchart there is a simple decision to see if the equipment is online or not. If not, the run is completed. Runs are only valid, in this template scenario, when the equipment is connected and initialized. The decision node has a condition, which must be provided declaratively, using Visual Basic Expression syntax. The Expression Builder editor provides full IntelliSense support for the run object. We'll just quickly retype the expression to demonstrate the IntelliSense. Here we are using the run object helper to retrieve the current equipment record from the database. We then compare the value of the automation state field with the required automation mode from the equipment configuration to determine if the equipment is online. The activity close run node is used throughout the workflow. The source for this code activity can be found in the activity close run.cs file. It provides a typical example of the structure of a code activity used in a CoreTegral automation workflow. We'd suggest that you spend some time examining the source code, in particular the mechanism to define input and output parameters. The final flowchart node at this level is a parallel construct. This allows the flowchart to process run logic, whilst simultaneously listening for asynchronous events. Double-click on the Handle Global Events node. Here we have an event handling loop. The CoreTegral event listener activity at the top is a standard CoreTegral component. It can be used to listen for events from any component in the solution. Every instance of this activity in the workflow is essentially a queue of incoming messages from all linked components in the solution. Each time the logic reaches here, it will either get the next message in the queue, or wait for one to arrive. As events arrive, they are examined and filtered down through the decision tree and the appropriate action is taken. Let's now move back up one level and look at the other side of the parallel activity, the for each run state activity. It loops through all the required stages of the run: verify, load, pre-process, etc. The stages are obtained from the configuration with the systems from the run object. The run state flowchart is initiated for each state. Double-click on the run state flow. Here we can see the first logic checked is to determine if the run has already been completed, perhaps by an asynchronous event. If so, the workflow is terminated. If not, the run state is changed to the new required state. A code activity logs this in the database and informs the necessary components. The switch construct then decides on the next logic to invoke depending on the current run state. The logic for a state is contained within its own flowchart construct, which may be empty if no custom logic is required. If there is no branch for a required state, the state is just logged and the loop moves on to the next state. Since the required states for a run are configured on the Equipment Manager component, the mechanism allows a superset of predefined states to be handled by the workflow, but only specific ones enabled in the Equipment Manager configuration, as required. Taking just one state as an example, let's view the pre-process flowchart. Here we can see a sequence of activities are performed, and then the logic stops. This is the end of the logic tree, and the logic completes, allowing the higher level loop to move on to the next state in the run. The actual contents of this state send a start command to the equipment using a code activity. The VF string for the start command is obtained from a custom method on the run object. The result is checked, and run completed if necessary. At this point the logic stops indefinitely and enters an event loop where it waits for a VF event from the equipment server component, indicating that the run has started processing on the equipment. This then allows the logic to complete and in turn allows the higher level loop to move on to the next stage of the run. In this tutorial we have described in more detail how the default workflow component within the Equipment Manager template is structured. For more details on this workflow, please review the CoreTegral user guide, which can be found in the installation folder. Thanks for watching this training video. If you have any questions or suggestions on how we can improve our training material, please contact us. Goodbye.